Welcome everyone to the second installation of the Microwatt Momentum Open Hardware Hackathon from OpenPOWER Foundation in collaboration with Chip Foundry. I want to thank everyone who has already submitted their proposals. We got overwhelming response, which we're really excited about, and we've gone through a lot of these submissions already, and we'll be sending out an email congratulating those who have actually been accepted to the next phase of the round. Um, and if you weren't selected, we still appreciate your participation. We definitely plan on doing more of these in the future, so don't get discouraged. There's lots of good ideas, and we're just really excited that so many of you actually proposed and actually are looking to do something with microwatt and power. So with that, I'd like to hand it over to Peter, who's going to talk a little bit more about what's coming next.
Right. Thank you, James. So, like James already mentioned, we were really overwhelmed with the level of participation, and I'll also add my thank yous. Right, this is really truly wonderful. There were almost 300 registrations. Now that number is a little bit generous because I know that some of you seemed, maybe quite worried about whether you were going to get your registration in, and we had multiple entries from the same email. But when we looked for the projects, tried to find a README file or another file that was named in such a way that it suggested that it had a program, a description of the project that you were proposing. We found about 100 of those, and it's actually, I think the number was 107. But a few of them have multiple emails associated with it. So I'll talk about that a little bit longer, but later. But overall, really, really fantastic level of engagement here. So I think Jeff just hit send maybe on emails to people that for which we found the project descriptions. So if you didn't get an email, it means that we could not find a README file describing your microwatt project, right? So for some people, there was no public repository of any kind, right? So we didn't find anything. For some of you, you had public repositories, but nothing seemed to be microwatt specific. So, then also we didn't admit you. However, our intent here is, of course, to let as many people work in phase 2 as possible. So if you did create by the deadline a description of your project, and for some reason we haven't been able to find it with the link that we had. So if you did create a project before the deadline, and it's just that we haven't been able to find your project description, please send me an email, and the address is down here. And please do so, today or tomorrow, with a link to the correct file. Don't modify or touch the file, right? Because the file should have existed by the project deadline. So again, congratulations to those of you that already got an email. If you did create a project description and you think you should be in, but you're not, drop me an email, and I'll try to find the file. We would like to admit as many people as possible to phase 2. The proposals had a very wide range, which is wonderful. It ranges from proposals to make enhancement to the microwatt core itself. A lot of proposals propose adding some kind of an accelerator to the SoC. Other proposals, make some other suggested change to the SoC, like adding a new kind of peripheral on the SoC. there were a number of proposals that are proposing to make improvements for security reasons to microwatt, which, again, is a wonderful topic. There were a few proposals that actually propose an integrated solution, so make modifications to cell for to microwatt for a very specific purpose, and create an SoC for that. Again, wonderful. Also, a number of submissions are proposals for design tool enhancements, and I think that is great as well. But do keep in mind that submissions, of course, do have to include a tape-out ready design, and including the microwatt core, and we'll get to that in a little bit. So for the final phase here, right? In this first round, we basically accepted all project proposals that were based on microwatt, right? We didn't try to filter yet on other criteria. Just as a reminder, for the full judging criteria, you can look at the challenge webpage at the Chip Foundry address that I have there. So when we get the final submissions, we will first do a number of sort of yes/no checks. And that is the design tape-out ready? Does it include a version of microwatt? And can we reproduce the design? So let me pass it over to Jeff here, and he will say a little bit more about what tape-out ready means and what you might be able to do to convince yourself your design is tape-out ready.
Sure. Thanks, Peter. So what we'll be looking for the final submission is that you've utilized the template that we provide for OpenFrame, right, to implement the design. So there's a GitHub repo template, and we'll provide some further kind of steps and guidance and information around how that how to get started to make sure that, and how to begin the design, right? And you populated that with your design implementation. And all that should be checked back into your repo, right? So all your source files should be checked in. Your open lane configuration should be checked in. And then we're also going to require you to run MPW pre-check, which is a tool as part of the template in the process. And you run that locally on your design. And that MPW pre-check tool runs through a series of checks to ensure that your design meets the requirements for integrating into the final chip, and everything kind of meets the requirements for tape out, for us to be able to run the tape out process. So that's and then we're going to ask and require that you check in results from your MPW pre-check as part of your repo and submission. So we'll follow up with some further specifics and details, exactly what the specific list of what we're looking for in the repo, but just as a kind of a preview, it's going to include basically you submitted your design, your configuration for implementing your design. The final GDS obviously should be in the GDS directory for your wrapper. So this is your I think it's called OpenFrame project wrapper or something like that. So we'll get that correctly articulated. And then the pre-check results. So anyway, more to come in terms of the specifics, which we'll communicate, but that's what we'll be looking for the final submission.
Great. And then of course, for the prize winners, we are going to certainly check that we can, reproduce your design, right? Because the big objective here is to create designs out there in the open that other people can benefit from. So that last check, will help us establish, at least for the prize winners, that indeed, we can recreate your design with the documentation that you've provided. And then, after these sort of yes or no checks, There is there's a number of criteria. This is not a not a complete list, right? But things that will be important is the quality of the functional validation, right? If you made some kind of enhancement, we'd like to see some evidence that that enhancement actually works through a test bench or some related mechanism. The quality of the physical implementation, right? So you of course passing the design checks shows that you have at least a base level of quality, but maybe some designs will have an exceptional level of quality in the physical implementation. Quality of the documentation is important because again, we're doing this not just for you, but for others to later leverage and build on the efforts of everybody here. And then, of course, things like novelty, the amount of innovation and so on. And by the way, these categories are not in strict order, right? So if a project is not particularly novel in its functionality, but really is standing out in terms of the quality of its implementation, it's still a candidate for the prize, right? Now, of course, if there's a high quality implementation with excellent documentation that's also very novel, then those will likely come to the top of the pile. And then a few final notes here before we get to Q&A. So as I mentioned in the beginning, a number of projects seem to have multiple emails associated with the same repository. There's no intrinsic problem with that, right? We hope that there are teams working on things. But for those cases where I have multiple emails for the same repository, I'll send out an email asking for clarification as to which of these emails we should use, because we would like to ultimately have just one email associated with each project. We also, I think a lot of you are already in the Discord channel. I counted, there's about 100 of you there, which is roughly the same as the number of projects that we've admitted into phase 2 here. That is the place to ask questions. So please don't use my email, to ask questions. That's really only, for things that I initiate, asking about for clarification as to what email to use. With the exception that if you decide to withdraw from the hackathon, then please do take the initiative and drop me an email, because that saves us work further down the line, right? Then we don't waste our time checking. If you want to expand your team, and for example, for those people that might not have made it into phase 2, but they are on the Discord channel, and if you have a project but you think you could use more help, or in general you'd like others to join you, you're welcome to use the Discord channel and say, hey, I'm doing this kind of a project and I would love for others to join me. I think we welcome team efforts here. So you're welcome to do that. So to that, I think was pretty much it for the prepared stuff here. These slides, along with a recording of the webinar, will also be posted as we did with the first one on the hackathon site at chipfoundry.io. So with that, I think we can open it up for questions.
Great.
I guess the first question we already answered is.
Yeah, I think we covered that. So we will be sending out a link for the recording and the slides to everyone who registered for the webinar, as well as everyone who's participating in the hackathon.
Oh, by the way, I didn't mention this, but maybe it's a nice curiosity. I was, a number of emails are Gmail, registrations, so I don't really know where they're from. In terms of universities that seem to have a strong representation here, I'll give a shout out to Valor, VIT. And there were quite a few registrations from there. The Chennai Institute of Technology seemed to have quite a few registrations, and then NYU also kind of stood out in terms of the registrations. And if there may be other institutions that for which all the students use Gmail, so sorry if there's another one that is very heavily participating, but not not recognized. But these three, I think, were worth calling out.
Is there a JTAG implementation that we can use? Question that came
in. That is a good question. I think there is, but we'll answer it in the Discord channel. How about that?
Yep. Another question came in. The GitHub template that was provided already had multiple projects in it. What should we do? Okay, so maybe it's worth just reviewing that. So generally you're replacing, if you're looking at the open, I'm assuming you're referring to the open, the open frame user project. So that project, I'm actually looking at it right now. Let me go ahead and just share my screen, and I'll just go over a couple items on that again, just as a review. Try to find out where. Just give me a second. I think it's the right one here.
Good, and I see other questions coming in, so that's very good. We'll get to all of your questions.
Keep questions. Let me just go ahead and share my screen here. I'll just share my main screen. We'll do that. Okay, so hopefully you can see this. All right, so again, this is I'm showing the page for the challenge here, right? So you can find this navigate to this on the chipfoundry.io website. At the bottom, there's a set of links for resources, right? One of those is the first link here is start a project. So it gives you kind of a step-by-step, sequence to get started. You'll see here it talks about going to the Caravelle user project repo and then I'm sorry, I'm gonna get out of the way. And then the use template button. So instead of using a Caravelle user project, we're going to direct you to the OpenFrame user project, which I'll show you in a minute. But you'll be using that in place of this template to implement your project, right? But the rest of the steps all should follow. So you should be able to do the same set of steps basically to implement your project. You're going to update your so that basically includes cloning creating a template from and cloning your project locally, running once you go into your project, the root project directory, you can make setup to basically install the tools, install the PDK, kind of give you everything you need to actually start implementation. There's a location for where your Verilog should be within that for the wrapper part. It's in this Verilog/RTL directory. So you're going to be going into that. You'll find an initial file there. And what you'll want to do is you're going to replace basically all the examples, and we'll take a look at that in a second, with your own logic or your own design. After you have implemented your design in Verilog, you're probably going to run and create test benches. And I think we might have covered that earlier. But assuming you've been able to functionally verify your design, then the next step would be to implement the configuration for implementing your design in the OpenLane directory. and there's a specific file called config.json that needs to be updated. That both specifies kind of the design name and all the Verilog files that are part of your design that you need to update and do that, right? And then there's a final step to actually run the flow, in which case you're going to go to the project root directory, you're going to run and you're going to make the macro name. And again, depending on your design, whether it's flattened, there's only one macro, whether it's hierarchical and you have multiple macros, you're going to need to sequence through building each of those sub macros and then do the top level macro to complete the design. All right, once that's done, this is the step I was talking about earlier, running MPW pre-check. So this is already available as part of the template. There's a make target called run pre-check that you run that will actually automatically check your design. And it's going to run various sets of checks, including like boundary checks around the edge to make sure that that everything will, and as well as DRC checks to make sure everything kind of both can be integrated and will pass kind of all the physical verification checks required to be manufactured. And that will generate a report, which you'll find in a pre-check directory under your project. So that's a very high level. And then switching over to this is the Caravelle user project template I was referring to earlier, right? I've logged into GitHub, and you have to log in order to see this, but once you have logged into GitHub, you will get to see a button here called use this template, and you can use this template to basically generate your own repository, right? So you would do that, you provide a name, and it will generate a repository into your GitHub space. You'll then want to clone that project, right? Locally into your local design desktop. And then once you've done that, one of the things you're probably you're going to run the make setup command locally, which I described earlier. But then eventually you're going to come down and you're going to update the Verilog into the Verilog RTL directory. The top level is called OpenFrame project wrapper.v right here. The rest of this stuff is just all these are all just part of the example that's provided as a demonstration. So you can remove those and replace those with your own design files. Right, but here's where you're instantiating your design. In this case, this design is instantiating a timer, if I can find it. Where is it? I'll find it straight off here. Oh, here it is. Sorry. It's instantiating the timer right here inside of the top level, right? And it's connecting the IO from this macro to the IO of the external to the wrapper, and so it's making all those connections here.
And I think, Jeff, microwatt will show up inside sort of a user project something, right?
Yeah, correct. So typically, like if I had a microwatt core or something, I may instantiate that right here. If I have another higher level macro that integrates that plus other stuff, but this is where you would instantiate your core plus all the other and additional peripherals or other logic you attach to it. And again, you can implement this multiple ways. Like again, that could be implemented as a single like SOC sub macro, or it could be implemented, could be flattened within the wrapper.
And actually, there's one question I'll read out because it's quite related. It says, also you mentioned a template repository and an MPW pre-check. How can we access those? So I think you addressed that. So when you mean tape out ready, you mean it should include IO pads and pad rings, etc.
Right? No, what I mean is you've implemented the wrapper itself. So this top level here, this is actually a macro called OpenFrame project wrapper. So if I go into the open lane directory, this is where we're configuring each of the sub macros plus the top level. So the top level here is called OpenFrame wrapper. That's this directory here. Within that, there's a sub macro, I guess, called user project timer. In this particular example, where that's hardened separately. right? So that's hardened first, and then that's then placed inside of the wrapper and hardened, and then routed to all the I/O on the external to the wrapper. So you're not providing the pad frame, you're not providing the exterior pads on the GDS. You're only providing the GDS block for the wrapper itself. That then gets inserted into the final chip. The final chip includes the pad frame. Hopefully that makes sense. Let's see if there's an example of that here. So this is the GDS. So if I were to download that, open K-layout locally on my laptop here. Hopefully this doesn't switch over to a whole nother desktop. Good. And I'm going to go ahead and open up that layout I just downloaded. That is in my downloads. So this is what the user project wrapper looks like. And you can see basically at the edge here is just this is the boundary of this macro basically has pins along the bottom. I think mostly along the bottom, if I remember right, that you route your signals to, and that's basically that's what gets integrated into the final chip that has the pad frame. So the final chip has a pad frame that goes around this and inserts this macro into it.
And you're saying that final integration is done
right. That's done through a tape out process. When you submit this GDS to us, then we run a tape out process on our server to do that final integration. And then we provide that back, the final OASIS file back for your review afterwards, but you don't need to provide that or do that stuff. So in this case, this example was implemented here on the right side of the user process. So it's using a relatively small area, part of the overall area of the wrapper. But this is what you're providing. This is what you're building and providing back to us as part of your submission.
Yep. Good question.
Yep. And then just to give you a couple other pointers, and we can kind of do a follow-up on this later, but so I showed you, this is the GDS where your final GDS will land. There's also there's a set of device verification, design verification directories under Verilog. So there's a RTL directory. There's also a gate level netlist directory. This gets generated when you run OpenLane. So this will generate your gate level netlists. And then up this very top one here is for device verification. And this basically has all has example test benches and has a test bench system based on CocoaDB that there's additional documentation that describes how you can use that to build test benches. I think this one has got maybe one example in it, but let me just double check. Oh no, I'm sorry. There's a hello world example here in the CocoaDB directory for doing a test bench, for implementing a test bench, which you can take a look through that. And there's some additional documentation for how to extend that depending on the functionality of your design.
Then there's another question from Dhruv. The file that you just showed, he said, is that like a .left file? I guess the answer is it's actually more.
The one I was just showing here on K-layout is a GDS. So that's the GDS that gets generated. There is a left file also, I believe. So there's these other directories have like the left view as well as it's a library. I can't remember if this lib file gets generated, or I believe it is getting generated, but it's a sub micro. Yeah, and this is a magic file. Not exactly sure if OpenLane's generating that.
And I think
part of the flow.
Basically, your input into this design, right, is the Verilog files
Correct.
for your stuff, and then
Well,
the config.json, right, for
correct.
each
Yeah. So,
thing.
correct. So it's really
So
the
maybe
Verilog files, and then the config.json. And in this case, here's the example of the config.json. Right.
Yeah, and just about everything else I think is generated or
Correct.
downloaded.
Yeah.
But the Verilog and the config.json,
Yep.
you have to write.
And then that would be the inputs for implementing your design, right? And then obviously you'll, in addition to that, for your project submission, you'll have test benches for functional verification, and you'll have
Test benches, documentation, etc. Yes. Yeah, very much. Yeah.
And generally, this is the file I'm talking about. So basically, what you're going to be changing are things like the design name, but the towel, this one's not changed. I guess this design name is supposed to match the macro name, so that is actually supposed to stay the same. That should still say this should say Open Frame Project Wrapper in general for the top level, right? And then this is pointing to your Verilog files. If you're implementing a sub macro, then like this example this has a timer sub. This is probably a little more specific. You can kind of see the here's all the Verilog files for the sub macro. The name of the sub macro is defined here, right? Clock and other stuff is defined, but generally this is a lot of these things can be are common or the same as you don't have to change many of these things. You don't have to change in order to be able to implement your design successfully. The primary ones you will have to update, of course, are the Verilog files and the name of the design.
And then also the config.json, right, is where if some of the design reports give you warnings about certain things, like I think antenna rule violations or things like that. There's things that you add to the config.json to change some of the parameters.
Correct. Yeah. So you can
then
there are adjustments you can make
rerun
adjustments.
design.
You can make adjustments here. You can see some additional parameters and things here that can be adjusted depending on your design. I tend to not like for a lot of the prototypes, so we can get you maybe a little more follow-up, but I wouldn't be too concerned about antenna violations in general, unless you have an abnormally high number of them. For prototyping, typically don't chase down all of those. So
we probably need to provide a little more
guidance on
guidance.
that. Yeah. So
now I did find, when you rebuild some of the pre-cooked things, there's an example of previous projects that are just built into the open frame. And they also go through the steps of what to improve in the config file. I think it's a good thing to do to just get a little bit familiar with what is in the config file. But I think, Jeff, we should maybe give some specific items in here.
Yeah, a couple of things you should look here, right? Obviously, the clock period. This is so the clock speed. This is like kind of defaults to a standard here. The source of the clock, which is in this case the wishbone bus, which is common for a lot of projects that have a wishbone bus, or they implement a wishbone bus. This is another one, the macro sizing. So like this is a sub macro, right? So this is defining like a relative versus absolute configuration setting. So you can basically fix the size of the macro and say the area you must fit your macro will be this size, and you have to you're working to kind of fit the logic into that. Or you can give it a relative sizing, in which case it basically allows the size of the macro to vary based on the implementation, let it kind of optimize it. Right, and then this is because I picked absolute. This is basically determining the size, the die area size of it. The other one you'll probably want to worry about is the pin order config. So this is basically placing pins on the edge of on the boundary of the macro. And that's defined in a separate file called pin order config, which is right next to the config.json. And that's just basically defining kind of east, west, north, locations for all the pins. In this case, they're all in the west. So, but you can read more about that in the documentation as well.
And if you want your design to work in the little board, right, that you guys have, then you should make sure that your pin assignments are consistent with that.
Yeah, that kind of happens by default. So like when you connect to the project wrapper, right, your pin, the pins for the wrapper are fixed, so you can't change those. So you should not be removing any pins or adding any pins. All you're doing is connecting to what's there. And those automatically get routed to the pads, and then those pins are defined, right? So they're defined, all the GPIO, there's GPIO pins, and then there's well, for OpenFrame, it's mostly GPIO pins, and then there's of course power pads that are already connected to the power grid for the macro. So most of that's fixed, I think. But they're by using those GPIO, and they're numbered like 0 through whatever that is for OpenFrame. I can't recall. It's like 38. There's 38 for the Caravel, but there's like 44 or something like that, I think, for OpenFrame. Number of pins 40. Yeah, I think it's 44, 45. You're going to basically be mapping to those IOs, and then you can define those in any way you'd like. And you will be able to work with the existing eval board based on, you should be able to work with the existing eval board based on that definition. There are, well, with one exception, I guess there are, we may have to do a little more follow-up because my memory's not fresh on this, but there are a set of pins for interfacing with the flash that's on the board. And if those are kind of pre-defined, and you will want to make sure that your design, if you want to use the flash on the board, then you'll want to make sure you're using those pins are as you're implementing your flash controller on those set of pins, as well as the clock and reset pins should also be consistent. So we can actually take a look to see if I can, because I'm trying to remember now specifically what that is. Let's see, pull up the RTL. Okay, so there's already a reset pin defined because there's a built-in power on reset into the frame that you don't have to worry about. Yeah, so this is not showing, I'm not seeing any pins for the flash here. So that's one thing we can follow up on to give you a little bit more guidance if you want to use the external flash on the kind of pre-implemented development board. Then there's a specific set of IOs that you want to map the flash signaling to interface with that. We can kind of take that as a note, as a follow-up.
Yeah. And I think in the first presentation that we did, I think show some other links to projects that in fact already I think have those flash connections. So that would be another place where you can look to see how it's done.
Okay.
All right. So then there's I think we answered the questions from Dhruv, Aditya.
Yeah.
So there is one question here. What do you say about doing this hackathon solo? I think it's certainly possible to do it solo. At the same time, I think it's not too difficult to split the project up, right? So, for example, you can have one person who is more focused on on going through the whole design flow. You might have somebody who is focused on doing the Verilog design. You might have somebody who is focused on test benches. You might have somebody who is focused on writing really good documentation. So I think it's very, if you have multiple people on a project, I think it's very easy to put them all to work productively. But you can certainly also do it alone. It's going to depend on how much time you have available and how comfortable you are doing this kind of thing. Um, but again, I'll reiterate what I said before, right? Feel if you're working by yourself now, or if you didn't get selected for the second round and you'd like to join a project, feel free to use the Discord channel, to advertise that either you'd like to join a project or that you have a project that was approved, where you'd like others to join in.
All right, great. I think that's all the questions we have.
Yep.
Anything else, James, before we wrap up?
No, I'm looking forward to seeing proposals get worked on and what comes through. A lot of good stuff, and yeah, don't hesitate to ask questions in the Discord channel. We're there to help you guys out as much as possible. So yeah, looking forward to what you guys do.
Yeah, no, very, very excited. So far, things have been going swimmingly.
Yeah.
Yeah.
Super.
Yep. And just a
Well,
reminder, this is recorded, so it'll be posted again to the website. And yeah, we'll see you guys all in the Discord channel.
All right. Thanks, everybody.
thank you. Thank
Bye.
you.
Thank you.